My name is Terry Ryan. I'm a developer advocate with Google. If you have any questions or comments, probably the easiest way to get them to me is to my Twitter handle, which I forgot to put up here, which is just TP Ryan. And you can heckle me or ask questions or whatever you want to do there. So let me get right into it. The first question I like to kind of put out to all you folks is, who are you? Helps me know like what level I need to talk at and what jokes I can make, that sort of thing. So who here does full-time systems work? Okay. Who here does full-time development work? Who here does both? It's because you love DevOps, or your boss hates you and won't hire more people? Is it? I saw hands go up, yeah. Wait, how many people here tell developers or systems people what to do? How many here are bosses? Okay, good. I should have really asked that before I made a manager joke, but I think we outnumber you, so we're good. All right, I have two goals for this talk today. First is to introduce and showcase the abilities of our virtual machine platform, Compute Engine. And then I also want to show off some of the complementary technologies. One of the other things I will do is, I'm a developer advocate. I'm not a sales guy, but I will talk a little bit about pricing, just because from my perspective, a lot of the challenges that happen with VM projects are not technical. They're in fact usually pricing related. People go to the cloud and get surprised from a pricing perspective, and that sometimes damages those projects. So I will talk about that a little bit. But let's get right into it. Let's get into the basics and talk about Compute Engine. So Compute Engine is our VM platform. You can get anywhere from 0.5 to 96 processors, although we do have larger processor machines in beta, 160, I believe. And then anywhere from 0.6 to 624 gigs of RAM, and then in beta we have much larger machines available. You can attach up to 64 terabytes of standard disk or SSD, and you can do 3 terabytes of what we call attached SSD, which means in the 64 terabyte ones, those are just disks that are associated with your machine, but they're not like physically attached. The 3 terabytes of attached SSD are kind of on the nose. They are attached to the hardware that you're working with, which means you can get much higher performance and much higher IOPS out of them. And I can go on and on about the features and whatnot, but I feel like one of the best ways to kind of look at what our VMs can do is to actually configure one. So I'm going to do that live in front of you guys. I'm going to switch over to the demo machine, and let's build a VM together. So first thing I'm going to do is we see all the list of all the instances I have, and I'm going to create one. And let's see. So we'll call this delete me, because I will eventually delete it, right? Let's see, let's put it in, I can put it, in any of our data centers that we have around the world, but I will go with, let's go with LA. No, I'll go with Oregon for sentimental reasons. We'll be clear later. Let's see, so I'll put it in A of my options here. Now that's going to determine what zone and what region I put it in are going to determine some of the capabilities of the machine. Some zones don't have certain processor types. Other zones have different processor types or GPUs available or whatnot. So, and I'll show that off in a second. So the next thing I want to do is I'm going to configure my machine type, and you'll see we have a whole bunch of pre-configured machine types up to 96, and the aforementioned down here at the bottom, 160 CPUs. I'm just going to do that. I'm going to go 160 CPUs because I can, and Google will pay for it. That's a lot. Now, you know what? I don't want my boss to have to approve that kind of expense report. So, oh, well, actually, one of the things I can do here is instead of just dialing in on these pre-configured ones, I can actually customize. And let's say I want to do, 26 processors. I can. It's going to change the memory profile of what I can support, but I can do that. I can extend the memory if I want to. I can choose to set a minimum CPU platform if I want to. And then you'll see here that I do have GPUs available in this zone. I have a number of them. I'm not going to set them up, but they are available. Let's see. All right, so that's it for the configuring the machine. I'm actually going to go back to a pre-configured one. And then let's see, what else can I do here? Oh, I can change the boot disk, right? So you'll see I have a number of options for OS images I can start with. I can go with Ubuntu or CoreOS or SUSE or Red Hat or a couple Windows flavors as well, if that is the way you like to roll. I'm gonna just leave it to default. And I can also choose between SSD and standard. I'm gonna leave it standard just because I'm not gonna do a lot of computing with this disk, with this machine. I have this firewall control because obviously one of the most common things people do is just open up HTTP or HTTPS, but I can actually do a little bit more of that. I'll probably dig into that a little bit. Let's see, what are my options here? Security. I can set my own SSH keys, great. I can encrypt so all of our disks are encrypted by default. The only choice you get here is whether or not you manage the certs or we do. Customers can supply their key to encrypt that. It's great. Networking, we can look a little bit at the network settings. Every VM gets two network addresses. One is the private network and one is the public one. I can turn off the public one. I guess in theory I can turn off the private one. I've never done that because then I don't know how it would communicate with things, but you, in theory, can. You can give it a static or ephemeral IP address. You can create one, you can reserve one. And you can choose between our premium and our standard networks. Premium network basically uses our private backbone to transmit all of the data whenever, so a customer goes and pulls something from one of your VMs. It's gonna enter Google's network as close to the customer or user as possible, as one of our POPs, our points of presence around the world, and then travel on our network to get to whatever VM that you're going to. If you use our standard, we're gonna operate more like another cloud provider, in which case we will let it go over the public internet as close to it can before it has to go on our network. And so with the private network, the premium network, you get a little bit better, a little bit more regular performance, and it's on our network the entire way, so it's encrypted and secure. Let's see, what else do I want to show you here? All right, so that's it. Oh, one last thing I want to show you here before I click create is that, so I configured a whole bunch of things, and down here at the bottom is the equivalent REST or command line. I can actually click on this and get the exact gcloud command that I need to create the machine that I've configured inside in the interface here, which is awesome if you're building a whole bunch of these. You don't have to like keep going to the console to do it, and conversely, you don't have to sit and kind of figure out all the options in gcloud. You can just grab this, run it, dump it into a script, edit it, and use it repeatedly to build your machines. I'm gonna go ahead and build this. And we like to say, or I like to say, these will spin up in tens of seconds. Meaning, when I'm in my hotel room practicing this, it takes like 10 seconds. When people are watching, it takes longer. I don't know how it knows. It has performance anxiety, I guess, when people are watching. But in a moment, I should be able to see that this is ready to go. Hopefully, by the time I get back here, it'll be all ready. No, you're watching. Oh, no, there we go. All right, good, good. There's a little SSH button here, which is one of my favorite features, is that all of these VMs, you can just go right through the browser. We'll handle pulling down the SSH keys for you. And you don't have to, if you don't want to, set up your own terminal to connect to these machines. So all this will happen here, and you'll see that we're pulling down the certs, and I'm all ready to go. And now I can, I'm not gonna, well, bump it up a little bit, but you know, if I want to apt get update, this is Debian, and I'll remember that you need to be sudoed to do that. So bang, bang, there we go. And so there we are, all ready to start working with the machine, start pulling down software, and you know, I did it right in front of you guys in a couple seconds. Great. Okay, so I am going to switch back to my Prezo. All right, first thing is creating VMs. You can do this all scripted via gcloud. All of the options are available. All of the permutations are ready to go. The next step, obviously, would be running commands. And I was able to run commands to the SSH browser window. But I can also do them straight from my, from remotely using gcloud compute SSH and then the command. Also, if I want to copy files onto it, I use gcloud compute SCP, source, and then destination, and that'll copy files over. So with those 3 commands, I can pretty much do a lot of migration tasks, right? I can build a machine, install software on it, and then push my code to it and have it run. And so all 3 of those combined, and that's pretty much how you would approach migration. Let's talk about some of our images. I'm going to talk a little bit more about disks in a moment, but for images, we have multiple flavors of Linux and multiple flavors of Windows. You are free to use any of those or bring some of your own options, and I'll talk about that in a moment. But there they are. There's some of the options. Next thing is I talked about IP addresses, right? We said you can have public or private. You have static or ephemeral. We'll give you ephemeral addresses by default. But if you decide, not that this ever happens, right? But you start working with an IP address and realize you should have had a static address and you're afraid of losing it, you can take any ephemeral address that you get from us and just flip it over to be static for yourselves. And it's important to note that it only costs you if you don't use the static IP address. And what that means is, if you're using ephemeral, it doesn't cost anything. If you're using static and it's attached to your machine, it doesn't cost you anything. If you use a static one and you pull it off your machine and hold on to it, which you told there are plenty of valid reasons why you would do that, it costs you when it's not attached to a machine. And obviously the incentive here is that we would prefer you not park a whole ton of IP addresses and hasten the IP4 apocalypse that will happen any day now, as we're told. Probably happen at the same time the year of Linux desktop happens. So those are IP addresses, firewall. I showed you that you can open up HTTP or HTTPS. The firewall, actually, I'm going to switch back because it would be nice if I actually showed the firewall controls. So if we switch back to the demo machine, I'm just going to real quick set up a new firewall rule on this machine. So what I'm going to do here is in the console, I'm going to go over to VPC network, firewall rules, and we'll create a new rule. Let's go ahead and do that. You'll see that I give it a name. Let's call it MySQL. Oh, it's got to be lowercase, MySQL. We can turn on logs. I'm just going to leave it. Ingress, allow, deny, and we're going to call the target tag MySQL. And we will specify 3306. Great. Oh. And I'm just going to say it's open to everyone because that's great database administration. There we go. And then I go back to my machines. VM instances, delete me. I want to edit this, add a tag to it. Network tags, MySQL. And there we go. And just like that, this machine is now open on port 3306 to whoever wants to get to it. That's pretty much how easy setting up firewall rules are for these instances. So if we could switch back to the Prezzo, thank you. So that's firewall. Now let's get into some not so basic stuff. I think that's the getting started minimum that you need to kind of get your machine up and running. But let's talk about some of the things that make Compute Engine maybe a little bit different. So first we'll start with our images, right? You can start with ours, which I listed a whole bunch of them out, but you can always customize those images and then save an image. So you can start with our version of Debian, download all the software you need on it, get it all installed and ready to go, but maybe not put your code on just yet, and then create a static image of it, and then use that to build and boot your machines. So when you're building out fleets of machines, that's probably something you need. When you're using some of our other tools like instance groups, where you're making multiple auto-scaling machines, you actually have to do this if you want consistency on all the boxes as they get built. One of the other things you can do is boot from a container. There's this little switch up here that says deploy a container image to the VM instance. When you click on that, you get this whole other set of options. What you do is you point this at a Docker repo someplace. It could be Docker's one. You can pull down just from straight Docker, or you can use Google Container Registry, build your own images, host them there, and then pull them down there. It'll basically just launch Compute Engine with Container OS and Docker running, and shove your container in and just start it up. But it's kind of a quick, easy way to just get a container running pretty fast on our platform. All right, this one is really cool. So our Compute Engine VMs, by default, do what we call live migration, which means that when we do hardware or firmware updates on the machine, the hardware that everything is running on, we don't take down your VMs. What we'll do is we'll copy the entire memory space and the entire, basically everything that's going on, all the processing that's going on, and move it over to another instance seamlessly without you being able to notice. And what this allows us to do is we do maintenance. You'll never see downtime for our maintenance. If there is hardware failure of certain levels, you won't see downtime. And then one of the big pluses of this is for security updates. There's a firmware level vulnerability for Intel, or I'm sorry, it might not have been Intel, for a processor. We won't name names. A while back, and a whole bunch of our competitors, we all had, everybody across the industry had this problem. Like, we need to update the hardware because this is a zero-day exploit that's really scary. We were able to do that without causing any downtime to the vast majority of our customers that had live migration enabled. Other vendors had to have rolling downtime in order to handle this. I'm actually going to show a demo of this in action, because one of the things that you can do is you can force a live migration to happen. So I'm going to switch over back to demo. And we'll see here that I have a machine in my list of instances called migrate. Okay, and that has an IP address. So let's go to the terminal here. And I'm just going to start pinging it. Okay. And then, so that's pinging. And then in my other window here, see, there we go. I'll make this a little bit bigger. I realize I'll not be able to see it. There we go. But you'll see there I have the gcloud command to simulate a maintenance event. Simulate a maintenance event means tell the VM that it's having hardware maintenance, and it will do a live migration. So I'm going to hit migrate here, and at the same time I'm going to bump this up. And you'll see that we're getting relatively consistent ping times, anywhere from 10 milliseconds to I've seen up to about 200 milliseconds. Some of this is obviously dependent on the network that I'm running on, because it has to go from this machine to Google. But we are moving this machine right now, and you'll see that there's almost no disruption. Now, if you have a more advanced service, if you're like, because I'm just doing a ping, right? That's not that taxing on the machine. What we've seen is that you won't drop connections, but some connections may take just a little bit longer to answer while it's in the process of migrating. But we are still migrating, and we haven't seen any downtime yet. And we won't, because we're done. And we've just moved a machine from one piece of hardware to another without us seeing it surface at all at the connectivity level. What do you guys think of that? Is that something that you guys could use? Is that? No? Oh, okay. All right, tough room, guys. You just had the keynote, right? All right. So I'm going to switch back to my Prezzo, and we'll go a little bit deeper into stuff. All right, so some of the options that I didn't touch here is that you absolutely can attach GPUs to your machines. We have several types of GPUs available, mostly NVIDIA, Tesla K80s, P100s, P4s, T4s, and V100 GPUs. Now, it's important, I put this right after live migration because these are things that are specially attached to the hardware that you're running, and so basically you can't do the live migration with them running. Right? If you are running GPUs, you cannot do a live migration operation, which kind of makes some sense, right? Because we have to have the hardware. The hardware is connected. We also have available something called TPUs, which are Google's custom tensor processing units that are optimized for ML operations. Ooh, that's a bad spelling. They are now available for preemptable pricing, and I'll talk a little bit about preemptable pricing when I get to the pricing section. But basically, if you have advanced, or you just have ML work, and you want to kind of turbocharge it, switching to TPUs and activating that option in your TensorFlow or Cloud MLE or Cloud Machine Learning Engine boxes will make those operations faster and ultimately cheaper. Okay. We're going to take a slight detour, and I want to talk about something called Cloud Shell. So a lot of times people set up VMs and set them up as a workstation, right? They have one kind of systems workstation that they set up and use that to connect to their entire cloud infrastructure. And you can do that. We're happy to have you do that. But we also have Cloud Shell available for you, which is a browser-based terminal CLI. You saw the SSH window that we kind of give you, but we also have it kind of hooked up to a custom VM that is always available for you. It has a home directory, so you can store commonly used scripts there and have them migrate with you as you're working on them. But we don't charge you anything for it, so you can just always have it available. And I'm going to switch back and show it just how to get to it and how to use it. Up here at the top of my console, there's this little terminal-looking thing. I'm going to go ahead and activate Cloud Shell. See, it's going to provision a machine for me, and I can always open this in a new window. And we'll see that we're establishing a connection. And what's great about this is I don't have to maintain any of the software on here. I can use gcloud projects, let's say projects list. And so gcloud is running on this. It's all up to date. It's all the latest version. Same thing with the Kubernetes controls. Same thing with most of the kind of universally used on Google Cloud tools. They're all updated already for you to use. So I'm going to switch back. And, let's talk about metadata. So one of the cool things that we have built into our platform is the metadata platform. So whenever you're using one of our machines, you have access to this storage space. It's a key value storage space where you can find out information about your VM, you can find information about your project, or you can even put and take out custom metadata. And I actually do have a quick demo for this, just because it's kind of interesting. So I'm going to switch back here. And I'm going to go, and I have some commands already written out because they're long. So let me go ahead and copy and paste this. And let's go to, and we're going to log into the delete me machine that I made. And we're going to try and find some stuff out. So what's really helpful about this, if you're doing anything that you need to pull the IP address of the machine, or you want to write code that you don't have to hard code any of the names of the machines into, but when you're running, grab the name of the machine from, or different things about the project, you can pull them from here. So what I'm going to do is drop this in, and you'll see I had the enter there, but basically I just curled metadata.google internal compute metadata instance name, and I got where'd it go? It was there a second ago. There you go, delete me. So that was the name of the machine. And I can also do that at the project level, right? So I can go back here and let's grab this one. So again, a lot of times I'm writing custom code and I don't want to know, I don't want to hard code any of the project details into it. I can just use this and get this. One important thing is that you want to always make sure you include that header down at the end of it, the metadata flavor Google. Otherwise, it'll return an error. But basically, any of the SDK for any of the language runtimes that you might run on here usually have this built in, so they can just pull this information. But you can get to it directly and deal with it however by just grabbing the URLs. This is all secure, so for machine metadata, It's actually doing a process under the covers, and the request and the data never leaves the VM itself. For project, I also believe that it's grabbing data that's locally, but I'm not 100% certain of that. But just be aware that you can trust that that data is not being transmitted anywhere. All right, I'm going to switch back to Prezzo. Metadata. So now let's talk about pricing. And like I said, pricing is a giant hurdle, I think, a lot of times with VM projects. And basically, the logic goes something like this. It used to be the case where you overbuy hardware, right? Because you're going to amortize it over 3 or 5 or 8 years. And so you want it to be able to grow to your usage 3 to 5 years from now. So you overbuy. Which is totally valid strategy when you're doing on-prem stuff because you're planning for growth. But then you do that same process and you go, oh, well, I'll go to the cloud and I had 10 64 CPU boxes. I'm just going to repeat that and do the same thing. And you get this bill that's sort of outrageous. And that combined with the fact that you're not actually using all of that processing power means that you're not just overpaying, you're overpaying for stuff that you're not using, right? So we have a couple things to encourage strategies for you to kind of curb your usage to kind of conform to the way that you'll get the best pricing on us. Wow, that was a complex sentence I just said there. All right, so let's start with the first one, which is our sustained use discount. So one of I kind of talked through that whole process where you overbuy and you plan for growth. Well, we do that too, right? So we take on a risk and buy extra machines in the hopes that people will use them and pay us for them. That risk is still there, and that's still a risk for us. So anytime that we can push that risk onto our customers, we'll make a deal, right? We'll lower the price because it's good for us to share some of this risk. So if you have long-running machines, that's good for us, because the longer and more consistent you guys are running machines, the more easy we can plan for growth, right? Because it's more consistent. So we like regular usage. We like long-running machines. So the longer you use the machines, the longer we'll give you a discount. So you get up to 30% off of our list price over the course of a month for running a VM. Now, it's important to note that this is calculated over all of your instances and not just 1 or 2. So for example, if you spin up a box for half a month and then spin up another box for half a month, we'll actually combine that into a full month of a box, even though they were separate. We call that inferred instances. So let me kind of show you how this looks from a machine standpoint. So day 1, end of month, I start with 1 machine, and I run it for half the month. And then I need to add additional capacity, so I'm running second machine also for part of the month. I add a third machine for the back half of the month, and then I add some extras, right? So I'm running 5 machines total. None of them are running for a full month, so you wouldn't necessarily expect to get the full discount. But what we do is we lump these all together, right? So we cut off 5 and split it into this, and basically we kind of go from the start of when the machine ran the earliest and then plan out for a whole month. We'll see that 1 and 3 combine to become a full machine. 2, 4, and 5 combine to become a majority of a machine, and 5 is partial. So then we calculate the discount by saying, okay, this set of machines that we are counting as 1 gets 100% of the discount, 30% off. The second one ran for about 80% of the month, so we'll give it 80% of that discount. And then the fifth one ran for just around 25% of the month. And so that's how we'll calculate your sustained use, not just on each individual part as it relates to a month. So more you run, the cheaper we are, and we're happy to have your consistent usage. Okay, so that's sustained use discount. And the great thing about that is you don't have to do anything. Like if you want to game it, you can certainly kind of fool around, kind of make sure you're getting the best one you want. But if you just run a VM, we just apply this automatically. There's no switch you have to flip or anything. So the next price control we have is something called committed use discount. And we fought this for a long time because committed use struck us as decidedly uncloudy, right? You're taking a machine and saying, I will run this machine for 3 years. I'll run this machine for 1 year. which basically you just moved your hardware commitment from your data center to us without really taking advantage of the fact that on the cloud, if you need more, you can ask for more. If you need less, you can ask for less. So we do it a little bit differently. You're not committing yourself to a machine. You're not saying, I will have this one 64-core box for the next 3 years. You're paying for an allotment of processors and RAM. And we'll give you up to 50% off depending on your configuration or whatnot. But here's the thing, you can configure this however you want, and you can change it at any time. So let's say I agree to buy 320 cores. Memory would also apply, but it would make the math a lot uglier, and I can't do math on the fly. So we'll just say, for the sake of argument, this is just our processor allocation. Memory is also involved, but we're not going to show it. So I have 320 cores. I split it up into 16 20-core boxes. Great. Further down the road, I figure out that, like, man, I really need a beefier machine to do this one set of operations. Well, what I can do is tear down the 4 of the 20s and turn it into an 80, and this is still the same thing, so it's still the same discount, it's still the same everything, because it's the same number of processors total. And I can do it the other way, right? I can go lower, I can break up some of my machines into smaller. I can do whatever as long as I'm still at the same processor allocation. The committed use discount will apply, and all of our agreements are all in place, which is great. Now, if you need more, obviously you can do committed use along with other strategies. You can just buy an extra VM. But once you commit to this, you will pay for these for the term of your commitment, regardless. So that is another way. All right, so that has been pricing tricks, and now I want to talk about some of our usage controls. So we have something called custom VMs. I showed you could dial in exactly the number of processors and memory that you wanted. And what this allows you to do is, a lot of times you look at those preset configurations for machines, right? You've got your 2, your 4, your 8, your 16, your 32, your 64. But like, you may find that one of your processes runs perfectly at 20 processors, right? Like, that's the optimal. So you're kind of left with a choice, right? Do you underspec at 16 and maybe not be as performant as you possibly can be, or do you overspec at 32 and just say, well, I'll waste that money because, I'm not paying it, right? My boss is paying it. But what you can do is dial in exactly to 20 with us and get the exact performance you need for as little money as possible as you can pay for it. And actually, I have a demo of this. So I'm going to switch back to the machine here. And I'm going to start this off and then explain what I'm doing, because it does take about 2 minutes to run. So I have here, you'll see, 32 machines ready to go. And I'm calling out to the APIs to request machines for them. And you'll see that's 2, 4, 6. It's all the permutations of custom VMs I can use. And what's going to happen is these boxes are going to spin up, and they're going to calculate 100 million digits of pi on each box as soon as they start up. And the reason why I do that is because that is a very processor-intensive operation. But the tool that we use for crunching pi, kind of at some point, you don't get better performance by adding more processors to it. And so what's going to happen is all of these machines are going to spin up, and we'll see which one does it the fastest, and we'll also see which one does it the optimal performance for cost. So the first part of what we're doing here was the requesting from our data center. So basically we say, hey, we would like a VM, and the data center takes a little bit of time to figure out, do we have capacity for this? Yeah, we do or we don't. But it looks like in most cases we did have capacity. The next thing it does is build, right? So we're going to take the processor and memory configuration that you asked for, find it in the data center, kind of lump them together, and then turn them into a machine. After we build, we're going to configure the network to make sure that it can talk publicly and privately. And then after it does that, it's obviously going to boot its operating system. And then the first thing it does after it's all done its boot operations, it immediately calculates 100 million digits of pi using Y-Cruncher. So we'll see this is happening. We'll see. I wonder which one is going to win. I know which one is optimal because I've done this hundreds of times, but it always surprises me which one wins. There's no real difference in terms of speed of boot process by how you configure your machine. It used to be that that the custom numbers were a little bit longer because we already pre-allocated some of the preset numbers. That doesn't seem to be the case anymore. And so let's see, we already have a winner. The winner was, wow, the screen is so big that I can't tell from here. I can't read it from here. Let's see. So 40 processors won, but we're still chugging along. This, like I said, this usually takes about 2 minutes to finish. So we're just going to let it finish out. And when it's done, what we're going to do is we're going to isolate just the pi calculation and look at the curve it creates. We're done that one, and that one should be done any second. So a lot of interesting observations. 41, but a lot of the the high performing ones were sort of down here in the lower processor range. So let's isolate pi calculation. And you'll see that we get a nice curve, right? This is definitely processor related, but eventually it kind of craps out and it doesn't get any better just because you add more processors to it. Having done this hundreds of times, it's around 28 processors is where it starts to become kind of, you're not getting benefits out of adding more machines. But as we see, 28, in terms of the total cost of how much this costs, we go from the smallest thing we could do, a 2-processor box, all the way up to a 64-processor box. And our price starts at 0.2 cents for that operation, all the way up to 6.5 cents for the operation. So one, we just calculated 100 million digits of pi on multiple machines that we spun up from nothing just right now, which is kind of cool. And we were able to figure out what the optimal processor was for this, or about 28. So that's great. I'm going to switch back to my Prezzo. And let's see. So that was custom VMs. Now let's talk about preemptable VMs, which is another strategy we have. Preemptable VMs are 1/5 the cost of our normal VMs. So just right out the door, just 1/5 the cost. However, they will disappear in 24 hours. Sometime in the next 24 hours, they'll go away. It could be any time in that 24 hours, but they'll definitely go away within 24 hours. You'll lose the machine. You get about a 30-second warning before it just kind of goes away. But then what you can do is, like, you can always request another one, and we'll give it to you. So what is this for? It's not for running your permanent, e-commerce or website presence. It's not for anything that's user-facing. It's for batch work. It's for work that you don't care when it gets done, right? It can support having an interruption and restarting. So queue processing, batch work, anything like that. So let's kind of show how this would work. So I have a machine here. This is the, what is this? This is the micro. We're going to bump it to the 1 CPU. We're going to bump it to 32, and then we're going to bump it all the way up to 96. And when we get there, we see that the price per month is $2,300. As calculated, that's $3,300 for the actual full cost of it, and then you're getting $1,000 off in the sustained use discount if you're running it for the full month, and that's how we arrive at $2,300. With preemptable VMs, what you get is the total cost drops, the original cost drops to 701 because it's 1/5 of that 3,500, but you don't get the sustained use discount, and then it comes out at $701. So this is a really great strategy for lowering a cost for operations that don't need to happen at a particular time, particular moment. I'm sorry, is there a question?
Yeah, can you speak to the restart? So you don't know when you're going to go down.
Yes.
How do you bring yourself back up? Do you do it like 5 times a day? Say you only got a 4-hour slot. How does that actually work?
That's a great question. So one, you can always just do it manually, right? You have to check to see if it's up and right, but we don't want to do that. The way most of our customers who are using this as a strategy do it, and I'm going to talk about this right now, instance groups, where you can create these groups that you say have a minimum, a maximum, have them always running. You can set them to be preemptible. So if one of those machines goes down, it'll start back up, and that's probably the best strategy for doing it. Yeah? Yes? No. So they will live at some time. They will live for up to 24 hours. So That is the longest they'll live. But they can, in theory, shut down immediately after you start them up. Because what's happening under the covers is we have machines that aren't being used, allocated in certain ways in certain data centers and whatnot. When you ask for one of these preemptible VMs, you're saying, I want it, but I don't want it that badly, right? So what'll happen is within that 24 hours, if another customer comes along and says, no, I need this machine all the time, and I'm going to pay the full price for it, we say, well, that's the deal we made, and we'll take it. So that's why you don't have any control over how long. There's like, maybe no one asks for it, you get it the whole 24 hours. Maybe someone asks for it immediately, and it's taken away. All right, I'm going to try to get through this next section, and I'll leave time for questions at the end. So, as I was saying before, one of the things, once you want to start scaling out, once you want to start making your operations bigger or a little bit more self-managing, what you're going to want to do is take the next step towards managed and unmanaged instance groups. These are groups of machines that are all connected to they're groups of machines. That's really all they are under the covers. They're not that useful unless you hook them up to a load balancer, in which case then you can have them share responsibilities. But you have a managed or unmanaged group. Managed groups, you have to create an image template. So you'll create a disk, like I outlined before. You'll create a machine profile, and you will say, this is the template for this, and create machines in this group to this template. Then, because they're all exactly the same, we can do things like auto scale and auto heal them. We can say, you can say like, have the processor utilization always be 60%. And so if it goes above 60%, we will spin up more instances for you. If it drops below 60% over all your instances, we will spin down one for you, with you being able to set min and max. So you may want to just say like min 3 all the time, right? Just so I have some redundancy and also some redundancy. And then set an upper limit, like this should never go to 20 machines. So if it does, there's a problem. So have the max be 20. Unmanaged groups are, again, a collection of machines that you hook up to a load balancer. The only difference here is that they're heterogeneous. And because they're heterogeneous, we really can't do no auto nothing, right? Like we don't know the impact of adding another machine because you have all different sets of processors allocations. That's fine. So you can set these up this way. And then finally, you're going to want to hook one of these up to our load balancers. And we have a couple different flavors of load balancer. Our HTTP HTTPS load balancer, which is sort of the equivalent of what other people would refer to as an L7 load balancer. TCP and UDP are network load balancers. It's our running at L4. And then all of these, either of these, you can set up to be internal only, so that it's only routing internal traffic. Now, I'm going to walk through the console of these things real quickly, but I'm not going to set anything up because it usually takes a little bit of time. So I'm going to switch to the demo monitor here. Oh, yeah, we're great. And let's look at this. So let's see here. We're going to start with our instance groups. Now, I have an instance group already set up. You'll see that I have 3 instances running, and I have a rule that the target CPU utilization is always 60. We can go in, and we can see this is a managed group, so that it will auto scale and all this. I have a template set up for it. I'm just going to go through and I'm going to mess around with the minimums here. I'm going to say minimum 5 instead of 3. And then I'm going to set the maximum to 10. And I'll save that. And all of this is wired up to a load balancer. So let me go here, and we'll see the load balancer. And this is pretty basically straightforward. I get a front end, which is my IP address, in which case this is an HTTP load balancer, so it's doing mostly HTTP. And I can set up host paths and rules, or I can just have it just completely load balance the whole thing. But I could set up multiple backends to work on different paths on the front end here, so I have a lot of control over that. And then down here, I have my backend services, which was that instance group I just showed you earlier. And so if I go to this IP address, you'll see my really exciting default Apache web page, because I was really kind of throwing this together quickly. There we go. So that's running. So that's one of those boxes is responding. And then finally, in that last step, I, at some point, updated the number of machines. And we'll see that it is currently spinning up those machines. They're basically, it's in the process of creating them right now, so that's why they're kind of labeled red. But because I said minimum 5 instead of minimum 3, that's why it's spinning up more. All right, I'm looking at my time, and I'm looking at my Prezzo, so I'm going to switch back to the presentation. And let's see. So a couple quick conclusions. One, there are other products in GCP that use Compute Engine as the underpinnings for the product. For example, Kubernetes Engine is using straight Compute Engine VMs under the covers, and same thing with Dataflow, Dataproc, and Cloud Shell. Why is this relevant? Why is this important? Because you can use some of the strategies you would use maintaining Compute Engine instances with these products. For example, Kubernetes Engine is for managing containers. You're running host nodes that run Kubernetes on it. You can do things like create a managed instance group that is made up of entirely preemptable VMs and have that support your container work. So you can dramatically lower the cost of running a Kubernetes Engine cluster by moving some of the work onto preemptable VMs because you can set that up all through Compute Engine. Same kind of strategies apply for Dataflow and Dataproc. And Cloud Shell has access to the metadata too. So all of these things add up. You may want to look at applying some of the stuff that we talked about here to one of these other products. Also, you get a free tier of Compute Engine just by having a project. So your first F1 micro instance is free in perpetuity. So it's not a very beefy box. It's a shared processor with 6 gigs of RAM. But if you just want to play around and start fooling around with VMs, if you haven't already, you can use that and kind of dip your feet in. With that, I will say this was, for me, a new talk, so please feel free to give me feedback. Obviously, if you liked it, great, but if you have constructive feedback, I would definitely love to hear it. So do that through the next app. All right, thank you, everybody, and like I said, I'll be around if you have questions. Thank you.